Hello, it's Professor Asma Praveen, Department of Psychology, Aligarh Muslim University. Today I will be continuing with types of variables. As we all know, in research, variables are the characteristics or attributes that can take on different values. These values can vary from one observation to another within a data set. So, variables play a fundamental role in data analysis and research as they are the entities under study or observation. Variables can be classified based on various criteria, and one of the criteria is the unit of measurement they present. And today I will be talking about the types of variables from the viewpoint of unit of measurement. And you can see from this figure that there are different categories of variables on the basis of their measurement unit. And the first variable on the basis of unit of measurement is quantitative variables. So this is the first category on the basis of measurement is quantitative variables. These variables consist of categories that can be arranged in a specific order based on their magnitude. These variables provide us with numerical data that can be analyzed using mathematical and statistical methods. By examining these variables, we can determine various measures such as means, medians, and standard deviations. Additionally, we can explore potential relationships between different variables through regression analysis. Unlike quantitative variables possess a distinct value. These characteristics enable us to perform mathematical operations such as an addition, subtraction, division, and multiplication on them. This flexibility allows for further manipulation and analysis of the data. In other words, we can say that quantitative variables in research are characteristics that can be measured and expressed as numbers. These variables represent amounts or quantities and are often used in statistical analysis. For example, if you are conducting a study on how exercise affects weight loss, the weight of each participant would be a quantitative variable. This variable can be measured in pounds or kilograms, providing a numerical value that can be analyzed statistically. Other examples of quantitative variables include age, height, income, blood pressure, number of siblings, temperature, test scores, and hours spent studying. All of these variables can be measured using numerical values. Quantitative variables play a crucial role in research because they allow researchers to collect and analyze data in a systematic and objective manner. By assigning numerical values to these variables, researchers can quantify and compare different characteristics or behaviors. This enables them to draw meaningful conclusions and make informed decisions based on the data collected. For instance, by measuring the weight of participants in a weight loss study, researchers can determine the effectiveness of exercise in reducing weight. Similarly, by measuring variables like income, researchers can assess the impact of certain factors on individuals' financial or academic success. In addition to their use in statistical analysis, quantitative variables also provide researchers with a standardized way of collecting data. By using numerical measurements, researchers can ensure consistency and accuracy in their data collection process. This allows for reliable comparisons and generalizations to be made across different studies for populations. For example, if researchers want to compare the average height of individuals from different countries using a quantitative variable like height in centimeters, ensures that the measurements are consistent and can be compared accurately. Quantitative variables are an essential part of research because they can be measured and calculated. Examples of these variables include the time it takes to commute, the number of children in a family, the price of a product, and the amount of liquid in a container. They all encompass the number of items purchased, the distance traveled, and even how quickly someone reacts to something. Additionally, quantitative variables involve the speed of an object in motion and the age at which someone reaches a milestone, such as walking or talking. Furthermore, they extend to the number of vehicles owned by a household. These variables are crucial for researchers as they enable them to perform mathematical calculations. By analyzing quantitative data, researchers can determine averages, standard deviations, correlations, and utilize inferential statistics to make predictions about larger populations based on smaller sample of data. This allows them to draw meaningful conclusions and gain insights into various phenomena. For instance, by examining the average time it takes individuals to commute from one place to another, researchers can identify patterns and trends that may help improve transportation systems. Similarly, understanding the number of children in a family can aid policymakers in developing effective social programs and policies. Moreover, analyzing the price of a product can assist businesses in setting competitive prices and maximizing profits. So, quantitative variables play a significant role in scientific researches. For example, measuring the amount of liquid in a container is crucial in chemistry experiments where precise measurements are necessary for accurate results. And studying the speed of an object in motion is fundamental in physics as it helps scientists understand concepts like velocity and acceleration. There are certain characteristics of quantitative variables, and the first characteristic is measurability. That is, these variables, such as height, weight, and temperature, can be measured using standardized units or scales. This means that we can assign specific units like inches, centimeters, Celsius, or degrees Fahrenheit to these variables. By measuring these variables in standardized units, we ensure accuracy and enable comparison with other data. Additionally, using standardized units allows for precision and consistency in our measurements. Next characteristic is mathematical operations. Quantitative variables are numerical values that can be manipulated using mathematical operations such as addition, subtraction, multiplication, and division. These operations allow us to perform various types of analysis such as calculating averages, observing changes over time, and utilizing statistics to gain insights from the data. Another characteristic is order. Quantitative variables are a type of data that can be ranked or ordered from lowest to highest. This ranking provides valuable information about the relationship between different values. For example, in a set of test scores, higher scores generally indicate better performance than lower scores. Another important characteristic is magnitude. Qualitative variables are an important tool for measuring and comparing the size or amount of something. These variables are represented by numbers which directly reflect the quantity being measured. For instance, when comparing the heights of two individuals, such as one person who is 180 centimeter tall and the another who is 170 centimeter tall, the person with the larger number is considered to be taller. Next important characteristic of quantitative variable is continuous versus discrete. That is, quantitative variables can be classified into two categories, that is continuous and discrete. Continuous variables can take on any value within a certain range and are typically measured. Examples of continuous variables include height, weight, and temperature. On the other hand, discrete variables can only have specific values that are distinct from each other. For example, the number of siblings one has, the number of cars owned, or the number of goals scored in a game are all examples of discrete variables. Understanding the characteristics of numbers is crucial for analyzing data, interpreting results, and drawing meaningful conclusions in various fields of study and decision making. By grasping these key aspects, we can delve deeper into the significance behind numerical information and apply it effectively. Now we will understand when to use quantitative variables. Quantitative variables are used to measure various aspects of our bodies, such as height, weight, and blood pressure. These variables provide specific numerical values that give us information about our physical characteristics. We can also use these variables when we need to analyze economic or financial data. That is, in the field of finance and economics, quantitative variables play a crucial role in studying economic and financial information. These variables provide us with the means to analyze data pertaining to various aspects such as income, spending, and market trends. By utilizing these quantitative variables, we are able to gain valuable insights into the intricate workings of these fields. Whether it is examining patterns in consumer spending or evaluating market fluctuations, these variables serve as a powerful tool for understanding and interpreting the economic and financial data. They enable us to make informed decisions and predictions based on statistical analysis, ultimately contributing to the overall understanding and advancement of these disciplines. We can also use quantitative variables when we need to analyze social phenomena. In the fields of sociology and psychology, quantitative variables are utilized to analyze and comprehend various aspects of social phenomena. These variables play a crucial role in providing insights into factors such as the level of education among individuals, rates of poverty, and statistical data related to crime. By employing quantitative variables, researchers are able to gather and interpret data that aids in understanding the complexities of the society. This approach allows for a more systematic and objective examination of social issues, enabling us to identify patterns, trends, and correlations that may exist within different populations. Through the use of quantitative variables, we can gain a deeper understanding of the social dynamics that shape our world. Educational attainment serves as an example of a quantitative variable that can be used to measure the level of education an individual has achieved. This variable can be categorized into different levels such as less than high school, and college degree. By quantifying educational attainment in this manner, researchers can examine the relationship between education and various social outcomes. For instance, they can explore how educational attainment impacts employment opportunities, income levels, and overall quality of life. By analyzing the data associated with this quantitative variable, researchers can gain valuable insights into the role of education in shaping individuals' experiences and societal dynamics. The poverty rate represents another example of a quantitative variable that offers significant insights into the economic well being of a population. It measures the percentage of individuals living below the poverty line within a given area or community. By quantifying poverty rates, researchers can assess the extent of economic hardship experienced by different groups and identify areas where interventions may be necessary. This quantitative variable allows for comparisons across regions and time periods, enabling researchers to track changes in poverty rates and evaluate the effectiveness of anti poverty initiatives. By studying the data associated with this variable, researchers can better understand the social and economic disparities that exist within the society and work towards creating more equitable conditions for all individuals. We can also use quantitative variables when we need to make precise comparisons. Crime statistics represent another domain where quantitative variables are essential for analysis. By quantifying criminal activities, researchers can identify patterns, trends, and risk factors associated with different types of crimes. This allows for a more systematic understanding of criminal behavior and the development of effective strategies for crime prevention. By examining the data associated with crime statistics, researchers can identify areas with high crime rates, explore the underlying causes, and propose targeted interventions to address the issue. Quantitative variables enable researchers to objectively measure and analyze crime related data, contributing to the development of evidence based policies and practices aimed at reducing crime rates and ensuring public safety. Quantitative variables play a crucial role in making accurate comparisons. So, we use these variables when we make precise comparisons. By providing a precise and specific way to compare different groups or individuals, these variables enable us to delve deeper into the data. This allows for more objective analysis and evaluation, whether it is comparing test scores, income levels, or population sizes. Quantitative variables provide a framework for conducting thorough and precise comparisons. They offer a valuable tool for researchers, analysts, and decision makers seeking to gain meaningful insights from data. Another area when we use quantitative variables is when we need to conduct statistical analysis. In statistical analysis, quantitative variables are commonly used to test hypotheses and draw conclusions about populations using smaller samples. These variables provide numerical data that can be measured and analyzed. By utilizing quantitative variables, researchers can gather information and make predictions about larger groups based on a smaller subset. This allows for more efficient and cost effective research methods. What is the purpose of quantitative variables? Quantitative variables play a crucial role in measuring and describing various aspects of our world. These variables utilize numbers to capture and convey information about a particular phenomena or attribute. For example, height, weight, and age are all examples of the quantitative variables that enable us to describe the physical characteristics of individuals. Another purpose of quantitative variable is to test hypotheses and make inferences. Statistical analysis is a powerful tool that allow us to draw conclusions about large groups by studying smaller samples. By using quantitative variables, we can test hypotheses and make inferences about populations. This means that we can gather data from a smaller group and use it to make predictions or draw conclusions about a larger group. For example, if we want to know the average height of all teenagers in a city, we can measure the heights of a sample of teenagers and use that information to estimate the average height of all teenagers in the city. This method saves time and resources as it would be impractical to measure the height of every single teenager in the city. Instead, we can use statistical analysis to make accurate predictions based on a smaller sample size. Another important purpose of quantitative variables include when we use these variables, uh, we can make accurate comparisons and draw meaningful conclusions about the differences and similarities between individuals, groups, or populations. These variables provide us with precise measurements that allow for in depth analysis and interpretation of data. Whether it is comparing test scores, income levels, or population sizes, quantitative variables enable us to quantify and analyze the information in a systematic and objective manner. These variables also help us to monitor changes over time. In order to monitor and understand the changes that occur over time, numbers play a crucial role. These serve as a valuable tool in assessing whether various aspects, such as the economy or people's health, are improving or deteriorating. By utilizing numerical data, we gain insights into the trends and patterns that shape our society. These numbers provide us with the means to measure progress and identify areas of concern, whether it is tracking economic growth or evaluating public health interventions. Numbers offer a quantitative lens through which we can analyze and comprehend the world around us. There are certain advantages of quantitative variables in research. Quantitative variables offer numerous advantages in our scientific research. The first is they provide precise measurements. That is, they allow us to analyze and compare accurately. This precision helps researchers to draw meaningful conclusions from the data. Additionally, quantitative variables enable statistical analysis, including measures of central tendency, dispersion, correlation, and regression. These statistical techniques provide further insights into the relationships and patterns within the data. Another important advantage of quantitative variables is the ease of interpretation. Unlike qualitative data, which can be subjective and open to interpretation, quantitative data is often easier to understand and communicate. This accessibility makes it more widely accessible to a broader audience, facilitating the dissemination of research findings. Quantitative variables also allow for numerical operations such as addition, subtraction, multiplication, and division. These mathematical operations make complex calculations and modeling easier, enabling the researchers to delve deeper into their data of research. Another important advantage of quantitative variables is they can capture changes in magnitude or quantity over time, providing valuable insights into trends and patterns. By analyzing these changes, researchers can gain a better understanding of how variables evolve and interact. The compatibility of quantitative variables with software is another advantage. Statistical software packages are specifically designed to handle quantitative data, simplifying the processes of data analysis and visualization. This compatibility streamlines the research process, allowing researchers to focus on interpreting and drawing conclusions from their data. Standardization is another benefit of using quantitative variables. Quantitative variables can often be standardized, allowing for comparisons across different contexts, populations, or time periods. This standardization facilitates the identification of similarities and differences, aiding researchers in making informed decisions and drawing meaningful comparisons. Quantitative variables are also crucial for building predictive models and forecasting future outcomes. By analyzing historical quantitative data, researchers can develop models that predict future trends and outcomes. These predictions aid in decision making and planning, providing valuable insights for various fields of study. Another important advantage of quantitative variables is based on facts and numbers because quantitative variables help us to minimize bias and subjectivity in the collection and analysis of data. By relying on quantitative data, researchers can obtain more reliable and objective results. Additionally, analyzing quantitative data is often more efficient than qualitative data analysis, particularly when dealing with large data sets or complex situations. This efficiency allows for rigorous scientific investigation and hypothesis testing in various research methods such as experiments, surveys, and observational studies. In today's era of big data, quantitative variables have become even more essential. With the abundance of information available, it is crucial to be able to analyze vast amounts of data quickly and extract valuable insights that can be put into action. Quantitative variables provide the tools necessary for this task. By utilizing these variables, researchers can uncover patterns and correlations within the data, leading to informed decision making and problem solving. Moreover, the use of quantitative variables ensures that research findings are grounded in evidence and can be replicated and validated by other researchers. This strengthens the credibility and reliability of scientific investigations. It also allows for comparisons and generalizations to be made across different populations or settings, providing a broader understanding of phenomena. In conclusion, we can say that quantitative variables offer numerous advantages in research and data analysis. They provide a reliable and objective approach, collection and analyzing data, allowing for rigorous scientific investigations and hypothesis testing. Their use ensures that research findings are grounded in evidence and can be replicated, strengthening the reliability of scientific investigations. Quantitative variables have various advantages in research, but they also come with some limitations or disadvantages. One drawback is the limited contextual understanding they provide. While numbers can be informative, they may not reveal the deeper meaning or context behind them. This can lead to oversimplification or misinterpretation of a complex phenomenon. Another disadvantage is the inability of quantitative variables to capture qualitative aspects. Emotions, attitudes, and cultural differences are difficult to quantify, which limits the comprehensiveness of research findings. Without a complete picture, important nuances may be missed. Measurement errors also are concern when using quantitative variables. Mistakes can occur due to using the wrong tools, biases in the selection of participants, or errors made by those being studied. These errors can undermine the reliability and validity of the research. Additionally, many quantitative methods assume a linear relationship between variables following a normal pattern. However, this assumption may not always hold true in real life situations. Consequently, conclusions or predictions based on these assumptions can be inaccurate. Representing complex relationships is another challenge for quantitative variables. They may struggle to capture interactions between variables, especially when dealing with multidimensional or non straightforward concepts. This limitation hinders our ability to fully understand and explain what we observe. Lastly, quantitative research may fail to account for unforeseen variables or factors that could influence outcomes. This omission restricts our ability to gain a comprehensive understanding of the subject matter. In addition to these disadvantages, quantitative variables also have some other limitations to consider. First, they relying solely on numerical data may overlook important qualitative aspects of a phenomenon. Numbers cannot capture the richness and complexity of human experiences or emotions. Second, collecting numerical data can be time consuming and resource intensive. It often requires careful planning, data collection instruments, and trained personnel. Third, analyzing numerical data can be challenging, especially for individuals without a strong background in statistics. Misinterpretation or incorrect analysis can lead to flawed conclusions. So, researchers must be aware of these drawbacks and limitations and employ complementary qualitative methods to ensure a more holistic understanding of the topic at hand. Strategies for using numbers effectively in research. To ensure the effective use of numbers in research, several strategies can be used. First, it is important to clearly define the research question and objectives which will guide the selection and interpretation of numerical data. Second, researchers should carefully design data collection methods considering factors such as sample size, data quality, and potential biases. Third, utilizing appropriate statistical techniques is crucial for accurate analysis and interpretation of numerical data. This may involve calculating measures of central tendency, assessing variability, or conducting regression analysis. Fourth, visual representations such as graphs or charts can enhance the understanding and communication of numerical findings. Finally, researchers should critically evaluate the limitations and assumptions associated with numerical data, acknowledging its potential shortcomings and addressing them appropriately. By implementing these strategies, researchers can maximize the effectiveness and reliability of their numerical research. Next category of variables is qualitative variables. A qualitative variable, also known as a categorical variable, is a type of information that is not expressed in numbers. Instead, it describes data that can be sorted into different categories. These categories provide insights into how often and in what way they appear in a data set. To better understand and compare these categories, researchers can use visual tools like bar graphs and pie charts. This helps to visualize the data and identify any important connections between categorical variables. For example, eye colors like blue, green, brown, or hazel, or states like UP, Bihar, Maharashtra could be considered categorical variables. In order to identify qualitative variables in research, we need to examine the research question and the research design and data collected. The research questions help us determine which variables are important to study, while the research design and data collected help us pinpoint the specific variables that will be measured. By looking for patterns in the data, researchers can also find variables that may require further investigation. Understanding qualitative variable is crucial in many fields of studies. They allow researchers to analyze and interpret data in a meaningful way. By categorizing information into different groups, researchers can gain valuable insights into various phenomena. Here are some examples of qualitative variables in research. Qualitative variables in research are non numerical characteristics that can be grouped together. For example, gender, marital status, ethnicity, education level, occupation, religious affiliation, and political party affiliation. Gender categorizes individuals into groups as male, female, or non binary. Marital status groups people based on their relationship status, such as single, married, divorced, or widowed. Ethnicity sorts individuals into different racial or ethnic groups such as African American, Hispanic, Asian, or others. Education level groups people based on the amount of education they have, ranging from high school diploma to a doctoral degree. Occupation categorizes individuals based on the type of work they do, such as teacher, doctor, engineer, accountant, or salesperson. Religious affiliation groups people into different religious groups such as Christianity, Islam, Buddhism, Hinduism, or others. Political party affiliation categorizes individuals based on their political beliefs and which political party they support, such as Congress, BJP, Democrat, Republican, Independent, or others. Analyzing qualitative variables often involves counting how many people are in each group to understand the distribution of these characteristics in a population or sample. By examining the number of individuals in each category, researchers can have deeper insights into the representation of these characteristics within a given population. Qualitative variables provide a way to categorize and organize data that may not be easily quantifiable. They allow researchers to explore the diversity and complexity of human experiences and identities. Here are some studies that are showcasing the use of qualitative variables in research. Research studies have shown the value of using qualitative variables in research. For example, in one study, a retail chain conducted a study to measure consumer satisfaction levels. The researchers analyzed qualitative variables such as the customer satisfaction level and the reason for satisfaction or dissatisfaction. By examining factors like product quality, customer service, and pricing, the study aimed to identify areas for improvement and understand what influences customer satisfaction. Another study focused on comparing student performance in different school systems. The researchers examined qualitative variables such as the type of school system, socioeconomic status, and academic achievement level. By analyzing these factors, including whether the school was public, private, the income level of students' families, and their academic performance, the goal was to gain insight into how these various factors contribute to differences in student performance across different school systems. These research studies highlight the importance of considering qualitative variables in research. By examining factors such as customer satisfaction levels and reasons for satisfaction or dissatisfaction, businesses can better understand what drives customer preferences and make improvements accordingly. Similarly, by analyzing variables like the type of school system, socioeconomic status, and academic achievement level, educators can gain valuable insights into the factors that impact student performance. These studies demonstrate the significance of qualitative variables in research and their potential to drive positive change. Types of qualitative variables. There are two main types of qualitative variables, that is nominal variables and ordinal variables. Nominal variables are categories that are not ordered in any particular way, such as gender, race, or religion. These categories can be represented using numbers, but the numbers themselves do not hold any quantitative meaning. For example, a researcher might assign the number 1 to represent males and 2 to represent females, but this does not indicate a numerical difference between the genders. On the other hand, ordinal variables are qualitative variables where the categories have a specific order. Examples of ordinal variables include educational level, income level, or the level of agreement. While these categories have a quantitative meaning, the distance between them is not necessarily equal. For example, the difference between high school and college may not be the same as the difference between college and, and PhD degree. Understanding the distinction between these two types of qualitative variables is important in statistical analysis. Nominal variables allow researchers to categorize data, while ordinal variables provide a sense of ranking or hierarchy among the categories. By recognizing the differences between these types of variables, researchers can accurately interpret and analyze their data. When to use qualitative variables? Qualitative variables are used in research when the variable being studied is categorical and does not involve numerical values. They are particularly useful in studying demographic characteristics such as age, gender, ethnicity, and religion. By using qualitative variables, researchers can divide a population into groups and compare differences between them. Another situation where qualitative variables are appropriate is when studying attitudes and beliefs. These variables can be used to examine people's opinions and perspectives on various topics such as politics, social issues, or religion. Surveys or interviews can be conducted to collect data on these variables. In cross cultural research, qualitative variables are often employed to explore cultural differences. Researchers may use variables like language spoken, nationality, or cultural background to identify groups for comparison. This allows for a deeper understanding of how different cultures vary from one another. Qualitative variables also play a role in market research, specifically in analyzing customer behavior and preferences. Variables such as brand loyalty, product preference, or buying habits can be used to gain insights into how consumers behave and make purchasing decisions. In healthcare research, variables are utilized to investigate patient outcomes. Factors like quality of life, satisfaction with treatment, or adherence to medication can be measured using qualitative variables. By identifying these factors, researchers can develop interventions to improve patient care. Purpose of qualitative variables. Qualitative variables serve the purpose of grouping data into different categories based on non numerical characteristics or attributes. They are used by researchers to describe and analyze things that cannot be measured, such as attitudes, beliefs, behaviors, and democratic characteristics. By doing so, qualitative variables help identify patterns and trends in the data. One main purpose of qualitative variables is to describe and categorize data into meaningful groups based on non numerical characteristics. This allows researchers to better understand and interpret the data they are working with. Another purpose is to compare and contrast different groups or categories of data, such as different demographic groups or cultural backgrounds. This comparison helps researchers gain insights into the similarities and differences between these groups. In addition, qualitative variables play a role in identifying patterns and trends in data that may not be immediately apparent when using numerical data alone. For example, they can be used to uncover cultural differences in attitudes toward healthcare. Furthermore, qualitative variables can be used to form hypotheses or research questions for further study. By analyzing the data and identifying potential risk factors or relationships, researchers can then design quantitative studies to investigate these hypotheses in more detail. Lastly, qualitative variables provide important information for decision making in various fields like healthcare, education, and business. For instance, healthcare providers can use qualitative variables to understand patient preferences and needs, which can guide treatment decisions. Similarly, educators can utilize qualitative variables to gain insights into student learning styles and tailor their teaching methods accordingly. In the business world, qualitative variables can inform market research and help companies make informed decisions about product development and marketing strategies. Overall, qualitative variables serve multiple purposes in research and data analysis. Advantages of qualitative variables in research. These variables play a crucial role in research for several reasons. Firstly, they allow researchers to delve into complex phenomena and gain in depth insights that cannot be obtained solely through numerical data. By exploring how people think, behave, and perceive the world, qualitative variables provide a comprehensive understanding of human experiences. Moreover, qualitative variables offer flexibility in data collection methods. Researchers can employ various techniques such as interviews, focus groups, and observations to gather information in different contexts. This adaptability enables them to tailor their approach to the specific subject matter and participants, enhancing the richness of the data collected. Additionally, qualitative research with qualitative variables facilitates the exploration of new ideas and the formulation of hypotheses. It serves as a catalyst for discovering unanticipated patterns or connections that may have been overlooked previously. This innovative approach expands the scope of research and opens doors to novel topics and perspectives. Furthermore, qualitative variables aid in comprehending the contextual factors that influence human behavior. They shed light on the social, cultural, and environmental factors that shape individuals' actions and statements. This contextual understanding is essential for researchers to grasp why certain behaviors occur and how all the pieces fit together. Another advantage of qualitative variables is their emphasis on capturing the thoughts and feelings of the study participants themselves. By directly hearing from those involved, researchers ensure the validity and relevance of their findings. This first hand perspective adds credibility to the research outcomes so they originate from the source. Moreover, qualitative variables contribute to theory building in research. The detailed and nuanced data they provide serve as a foundation for creating and refining theoretical frameworks. Through identifying patterns, themes, and relationships, researchers enhance our understanding of how things operate in various domains. Lastly, qualitative variables complement quantitative data by providing depth, context, and explanations. When combined, these two types of data yield a more comprehensive and holistic picture of the subject under investigation. The integration of qualitative and quantitative approaches enhances the overall quality of research outcomes. Another important advantage of qualitative variables is that they play a crucial role in research as they allow for deeper exploration of complex phenomena that cannot be fully understood through numbers alone. These variables provide researchers with insight into the meanings, motivations, and contexts behind people's experiences and behaviors. By allowing participants to express themselves in their own words, qualitative variables can lead to unexpected discoveries and new perspectives, patterns, or themes that enrich research findings. In addition to uncovering new insights, using qualitative variables also enhances the validity of research findings. By utilizing multiple sources of data and different methods, researchers can strengthen the credibility and trustworthiness of their interpretations. This comprehensive approach ensures that research is well rounded and provides a more accurate representation of the subject being studied. The incorporation of qualitative variables into research offers diverse benefits. It allows for a holistic understanding of human experiences and phenomena, which in turn contributes to evidence based decision making and social change. By considering the complexities of individuals' experiences, researchers are better equipped to make informed decisions and create meaningful impact. In conclusion, qualitative variables are essential tools in research that go beyond mere numbers. They provide researchers with a deeper understanding of complex phenomena. Disadvantages of qualitative variables. These variables, also known as categorical variables, have some drawbacks or limitations in research. One limitation is that they cannot be used for certain statistical analysis such as regression or ANOVA, which require numerical data. This means that there are restrictions on the types of analysis that can be done on data sets with qualitative variables. Additionally, unlike quantitative variables that have numerical values, qualitative variables are categorical and do not have numerical representation. This makes it challenging to measure relationships between variables or determine the size of effects. Another drawback of qualitative variables is the potential for misclassification. Since qualitative variables rely on subjective categorization, errors can occur if the categories are not well defined or if there is ambiguity in how they are classified. Furthermore, qualitative variables may not provide as precise or detailed information as quantitative variables. For example, while a quantitative variable like age can give exact numerical values, a qualitative variable like age group, for example, young adults, middle aged elderly, offers broader categorization with less precision. Comparing groups based on qualitative variables may not always be straightforward, especially if the categories overlap or are not mutually exclusive. This can make data analysis and interpretation more complicated. Additionally, there is the potential for bias in coding when analyzing qualitative data. The process of coding can be subjective and introduce biases if different coders interpret the data differently or if there is inconsistency in coding criteria. Qualitative variables provide valuable information, but their limitations must be acknowledged. While they offer insights into specific individuals or situations, it is important to recognize that these findings may not be applicable to everyone or every circumstance. Unlike quantitative data, which involves numbers and allows for statistical analysis, qualitative variables do not lend themselves easily to drawing conclusions about larger groups of people or different scenarios. Therefore, caution must be exercised when generalizing from qualitative research. Despite these disadvantages, qualitative variables are still important in research. However, it is important to acknowledge the limitations of qualitative variables and consider them when designing and interpreting research studies. Third category of variables is continuous variable. Continuous variables are measurements that can be made with a high level of precision. They include things like age, height, intelligence, and reaction time. These variables can be measured in very specific units such as years, months, and days for age. What makes continuous variables unique is that they can take on an infinite number of values within a certain range. For example, if a variable is continuous over a range of real numbers between x and y, it can have any value within that range. Continuous variables play a significant role in calculus and statistical theory. In calculus, they are often used in optimization problems. By understanding the behavior of continuous variables, mathematicians and scientists can find the maximum or minimum values of a function. This is particularly useful in findings in fields like economics, where finding the most efficient solution is crucial. In statistical theory, continuous variables are described using probability density functions. These functions help us understand the likelihood of different values occurring within a given range. For example, if we want to know the probability of someone's height falling within a certain range, we could use probability density function to estimate that likelihood. Understanding continuous variables is important because they allow us to make precise measurements and predictions. By studying these variables, we can gain insights into various aspects of our world, whether it is analyzing data in a scientific experiments or making informed decisions in everyday life. Continuous variables provide us with valuable information. These variables are measurements that can be made with a high level of precision. There are different types of continuous variables, and these can be classified into two types: interval variables and ratio variables. Interval variables have values that can fall within a specific range with consistent and meaningful intervals between them. However, they do not possess a true zero point. Instead, a value of 0 on the scale represents a reference point rather than the absence of the variable. For example, when measuring temperature in Celsius or Fahrenheit, 0 degree Celsius or 0 degree Fahrenheit does not indicate the absence of temperature but rather serves as a reference point. In contrast, ratio variables also have continuous values with meaningful intervals. What distinguishes them is the presence of a true zero point, which signifies absence of the measured variable. In other words, 0 on the scale represents a meaningful absence. Ratio variables are a type of measurement that include height, weight, age, income, and time. These variables allow us to do more meaningful math such as multiplication, division, and calculating ratios and rates. This is important in statistical analysis and research because it affects the types of analysis and interpretations we can make with the data. Examples of continuous variables in research. These measurements can take on any value within a certain range. For example, height, weight, temperature, IQ scores, personality traits, depression, anxiety levels, sleep duration. These variables provide researchers with detailed information that can be analyzed using various statistical methods. So, continuous variables are used in a wide range of fields from medicine to psychology to economics. They provide researchers with a wealth of information that can be used to better understand human behavior, health outcomes, and societal trends. Fourth category of variables is discrete variables. Discrete variables are a type of quantitative variable that can be obtained by counting. They are different from continuous variables, which are obtained by measuring and can take on any value within a range. Discrete variables can only take on a finite number of values or a countably infinite number of values. For example, the number of children in a household is a discrete variable because it can only be a whole number. On the other hand, the mass of an animal is a continuous variable because it can be any non negative number. In statistics, discrete variables are often represented by probability distributions. A probability distribution describes the likelihood of each possible value of a discrete variable occurring. For example, if we have a discrete variable representing the number of defective light bulbs in a case of 100 bulbs, the probability distribution would tell us the probability of getting 0 defective bulbs, 1 defective bulbs, 2 defective bulbs, and so on. This information is useful for making predictions and analyzing data. Discrete variables are important in many fields, including mathematics, statistics, and data analysis. They allow us to quantify and analyze data that can be counted. So, the next time you come across a variable that can be counted, remember that it is a discrete variable and can be analyzed using probability distributions. With the help of this figure, we can understand the difference between discrete and continuous variables. Discrete variables are those variables whose value is obtained by counting, whereas continuous variable is a variable whose value is obtained by measuring. Examples of discrete variable include the number of planets around the sun, number of students in a class, and examples of continuous include number of stars in the space, height or weight of the students in a particular class. Range of specified numbers in discrete variables is complete, while the range of specified numbers is incomplete in case of continuous variables. Discrete variables assume a distinct or separate value, while continuous variables assume any value between two values. Categorical variables play a significant role in data analysis, and they can be classified into three distinct types: constant, dichotomous, and polychotomous. These three are the divisions of the discrete variables. Constant variables are those variables that remain the same throughout the dataset, providing a fixed value for each observation. On the other hand, dichotomous variables have only two possible outcomes or categories. These variables are often used to represent yes, no, or true, false scenarios. Lastly, polychotomous variables have more than two categories, allowing for a wider range of possibilities. Understanding these different types of discrete variables is crucial when analyzing data and drawing meaningful conclusions. Constant variables maintain a consistent value across all observations within a dataset, which means that regardless of the specific data point being examined, the constant variable will always have the same category. For example, if we were analyzing a dataset on the colors of cars, a constant variable could be the make of the car, such as Toyota. Regardless of the individual car being observed, the make would remain constant throughout the dataset. Constant provide stability and serve as the reference point when examining other variables within the dataset. Next category is dichotomous variables. These are a special type of variable that only have two categories or labels. They can represent things like male or female, heads or tails, pass or fail, rich or poor. To create a dichotomous variable, we can separate values based on a specific point. For example, we could classify players with an average above 15 as high scorers and those with an average below 15 as low scorers. By using a bar chart, we can visually display the frequencies of each value, which allow us to understand how the variable is distributed and the proportions of each category. These variables are commonly used to group or classify data, and analyzing them can provide valuable insights into the distribution and relationships within the data. For instance, when analyzing survey responses, a dichotomous variable could represent whether a person agrees or disagrees with a statement. By assigning one category to agreement and another to disagreement, researchers can easily analyze and compare the responses. Dichotomous variables simplify data analysis by reducing complex choices into two distinct options. In contrast to constants and dichotomous variables, polychotomous variables offer more than two categories or outcomes. These variables allow for a broader range of possibilities, making them suitable for capturing diverse characteristics or opinions. For example, when studying political affiliations, a polychotomous variable could include categories such as Democrat, Republic, Independent, and others. By incorporating multiple categories, researchers can gain a comprehensive understanding of the population's political landscape. Categorical variables hold immense importance in drawing meaningful conclusions from the data. Constants, dichotomous variables, and polychotomous variables collectively contribute to the accuracy and depth of data analysis. Constants provide a stable foundation, while dichotomous variables simplify choices, and polychotomous variables capture the complexity of diverse categories. By comprehending and utilizing these categorical variables effectively, researchers can unlock valuable insights and make informed decisions based on the data at hand. This is all for today. Thank you.